we will have 9 speakers who will talk about ontology, methodologies, tools. And for tools, we have dedicated topics about ontology portal, tool interoperability, and as well as ontology validation. So my first speaker,
here, this one,
and the other next page. Yes, my first speaker is Clément Junket. Clément, are you online? Can you hear me? Is he invited to speakers?
Yes. Yes, you can access stage.
Hello, Clément.
Hello, you should be able
to...
to...
now I can hear you now, Clément.
Yeah, I was not invited as a speaker yet, so I was looking for the mic everywhere.
Yeah, okay. So, Clément, I know you will go for the topic on OntoPortal Alliance. I think there's no need I introduce him too much. I think a lot of people has known you for your contributions to AgroPortal. So I think I will just let you start your presentation. We can share from our end.
Perfect. If you can share on your hand,
Yes.
we'll go with that. And I apologize also a little bit if I run out of the workshop a little bit like that, but I was participating mostly in this session overall the whole workshop, and I have another webinar where I'm presenting actually very similar things to another community working on wind energy right after this talk at 3 p.m. So sorry if I have to run late, but I've seen folks like Eddie and Arco, who are also very good representatives of the work that we are doing together. So I'm sure they will be able to answer some questions or pass on some messages. Okay, well, we have been asked to do that quite short. I think it's a 10-minute talk, something like that. You do confirm?
Oh. Yes, so it's 10 minutes and then 5 minutes for Q&A before you leave.
Yeah. As efficient as I can. So just wanted to have, given the title here, Ontology Repositories and Semantic Artifact Catalogs with the OntoPortal technology, I'm going to give you some news about the OntoPortal technology, but if you do, so you do manage the slide, if you can go to the next slide, and I just show that I've been presenting a couple of times to some of the OntoCommons workshop, and thanks for inviting me and allowing me to give news about this work. And you will see that the term we use in this presentation now is Semantic Artifact Catalog. It's an expression we have now in the parent pack project, and that we use to encompass semantic artifact to encompass different kinds of semantic resources from ontologies, terminologies, vocabularies, and so on. And the semantic artifact catalogs is the term we use to actually describe those services, terminology services, vocabulary server, ontology repositories that actually help, or portals that actually help to manage and deal with them. So just wanted to give I have something like 20 slides presenting a few updates on the OntoPortal technology and things that are going on. I've been presenting a couple of times in those workshops. So you can move to the next slide. And if you do have the PowerPoint version of the slide, then you have to follow a little bit the clicking like that. But that's the introductory slide where I explain why ontology repositories are important. And we build an ontology. How do you let the world know? And you can go ahead on this slide. This is an animated slide. So if you need an ontology, where do you get it? How do you know whether an ontology is any good? Or do you find data resources that are relevant to your domain ontology? How could you leverage your ontology to enable new salience? All of those aspects are related to how can you use ontologies without managing them. Those are the points that I'm making in this slide. And if you move to the next point and the next slides, you'll see the vision about the FAIR principle. So you can sorry. Yeah, I'm quite fast with the slides, that's why. And if you have the PowerPoint version of it, you'll have to click a little bit like that. Thanks for helping me with that. So this is the one of the slides that I like a lot, because I use it from time to time, and I have used it in my previous talk. Ontology repositories, semantic artifact catalogs help to make ontologies, or help to make semantic artifact fair objects. So we believe that it's super important that if we want those research objects to be fair, we need to develop those repositories, those places to put them, serve them, make them accessible, make them interoperable one another, and then of course make them reusable by providing appropriate metadata descriptions, place to find them, protocols, etc. So the illustration that you see on images are really taken from the AgroPortal ontology repository that I work on with my group. And we believe that we address that. And it has been argued in a few papers since 2019, 18, 19. And now we also have even like concrete way of evaluating the level of fairness of a resource inside AgroPortal, for example. So you can move to the next slide. So AgroPortal, that's always that's a reminder. That's the project I'm leading at INRAE. I originally started at the University of Montpellier also, and this is really an ontology repository for agri-food, plant sciences, biodiversity data, environmental data. So the key idea is that researchers will have a place to put their ontologies, and we will provide a common interface, a common UI, a common API to actually query those miscellaneous semantic artifacts. Some are scarce vocabularies, others are in OBO, others are in OWL, most of them actually, and we all integrate, provide, connect them one another in the portal, and offer them to the community back. Offer the service of serving them to the community. So that's really the context. Just wanted to say that AgroPortal is always in line also with the OntoPortal technology, and that's really that's the next slide. You can move on. The OntoPortal technology is really what I'm going to focus a little bit on at the rest of the talk. But the key idea is that in AgroPortal we also develop some specific ideas. So sorry if the slide here is a little bit buzzy, but the key idea was to say we are moving on with new features in addition to the ones that we have by reusing the OntoPortal technology. And the challenge I will explain later is also to discuss how to move that back to the OntoPortal core technology. So we've been working on customizing our groups and categories, multilingual aspect, working on improving the annotator, working on improving the mappings, the fairness assessment module, supporting instance when you deal with our ontologies, being able to endorse costs, etc., etc. So those are aspects that you will not necessarily find in the classic OntoPortal technology, but that we have worked on. So the next slide shows the vision that by building and working on those ontology repositories, I've explained that originally BioPortal, a project that I know very well, I used to work there, has transformed into what we call with the OntoPortal technology, and we use that in several sectors, as you will see going to the next slides on. So French biomedical domain, the Chinese are using it in the biomedical domain. We are using it in agri-food, and here this is the latest example in ecology and biodiversity. So the complete picture is given on the next slide, where you see all the vision of the alliance and all the current partners actually, and you see, for example, here the industry portal that some of you have heard in the context of OntoCommons. And the other instance, MatPortal is also being developed by folks that are super close to OntoCommons at Fraunhofer. The key idea of OntoPortal is really to build the technology to provide those portals for community or project or domain, and help them, and together maximize the OntoPortal value, offering a state-of-the-art service, improve the software itself, the technology, increase the semantic uptake in different communities. Every time we set up a new OntoPortal, we see new users coming in. And overall, we also think in terms of long-term operational and financial health of the community, and the idea of also addressing specific needs in specific communities with specific projects is also a way to also scale up and scale on the long term, also with financial support or things like that. As you know, in academia, it's not necessarily easy to handle that. So this picture in the next slide will show you some of the newcomers. For example, in the context of the German and FDI for Biodiversity project, we're going to have a new project, a new portal in the biodiversity area, And for example, the DataTerra research infrastructure in France will have a portal dedicated to earth sciences. And we already have several community that we'll discuss with, for example, in astronomy, physics, sometimes in the social sciences, and a couple of discussions with some big companies. Well, AgroPortal is really making an OntoPortal is really in the wave of becoming a real open source project where everything is now on GitHub. We have consolidated a lot our procedures, our guidelines and documentation, and really you can see the community growing. So I'm explaining now that the project is really made naturally by default, intrinsically made to be reused by others. And that's really a change of philosophy from the time we're doing BioPortal, we're doing AgroPortal only. Now we think the features, we think the device, thinking about a generic approach for being reused in other communities. So the next slide just give you two information: the new OntoPortal website and the paper that is currently being submitted, and that I'm actually revising a little bit today. That will explain really in 20 page the vision behind that idea. You've seen that been using the same title here: Ontology repositories and semantic artifact catalogs. Well, I could not resist the presentation to include a few features that we've been developing and over the last 2 years since my last presentation in OntoCommons. So I have 3 slides about that, and then I come back on some of the topic related to OntoCommons. The first one is this one: AgroPortal offers now a tool that we call OFAIR, Ontology Fairness Evaluator. And we've plugged in a methodology that we have developed in my group that has been inspired from different approach in doing fairness assessments, so evaluating, formally speaking, how much a resource handle or deals with the FAIR principle. We do have a software running now in AgroPortal. If you upload an ontology in AgroPortal, and this is also available in Industry Portal, you'll see a couple of hours, actually the day after, you'll see the score being computed for that ontology, and then you can start improving your metadata and your ontology if you want to improve the fairness score. The next slide shows things that are going on also related to mappings. We've been doing a little bit of that. Some interaction and collaborations are also planned with our colleagues from Industry Portal on this topic, and trying to address the needs related with mappings, especially the ESSSOM community that is now providing a format for exchanging mappings. And we want our mapping repository, because OntoPortal is not only an ontology repository, it's also a mapping repository, to include and being more transparent with compliant with SSSOM. So we've started working a little bit on that. I'm not entering too much detail there. And I wanted to illustrate in the third slide, presenting the outcomes. Thanks all of the efforts that we've done to enhance the support for the scarce resources. We know that different communities doesn't have the same level of adoption of semantics, and some community really rely on terminologies and vocabularies developed in scarce, not necessarily ontologies. And so it was super important for us to be able to handle scarce more properly, and that's what we have since December 2022. We have been doing a release where most of the scarce features are supported now in our system, including collection and schemes that were not handled properly before. And we can say now that we have a state-of-the-art browser for scarce resources. And I even argue sometimes that we are even better than SCOSMOS, that used to be like the state of the art for dealing with scarce resources. Well, what's coming, I'm not going to detail too detail, but overall, soon AgroPortal will be fully multilingual. We'll be able to handle and deal with resources that are in different languages. We are rebranding the new user interfaces, and we are also consolidating the metadata model. The whole iteration that we did 3-4 years ago to improve the level of fairness, things like that, give us a lot of feedback on how to handle metadata on our side, and we are introducing back this feedback in our implementation. So the last slide was the last slide before two others that are about communication is, I mean, John sent me a few aspects that OntoCommons like to discuss or was on the table or were on the table for OntoCommons in your discussion. I'm not formally part of the project, so I'm just following from a long distance, and so I just wanted to mention them back in that slide. One of them was the limited tool support for concept identification, and I wanted to say, look, those are the things that we are doing typically with OntoPortal. We are providing a place where you can find your concepts and search. That's the basic really services that we offer, including also navigating, visualization ontologies, and also trying to facilitate the usability, the user experience, cost, the fact of being quite sustainable and robust. BioPortal, the original portal, has been up in the picture for more than 20 years now, almost 20 years. And AgroPortal is also on the scene for 6 or 7 years. So we are quite robust and sustainable, not necessarily like Google, but working on it. And then we have a aspect that in orange that we address a little bit, for example, the validation aspect or the need of integration with existing tools. Another session will talk a lot about validation today. We are not a validating platform, so OntoPortal does not provide a real tool like Maria's, for example, OOPS approach. What we are doing is providing a service that is sometimes the very first time ontology users deploy or push their ontology to or confront their ontology, their OWL file to, and sometimes we end up like really doing this validation work without really being in the position to do it. So because we parse the file, if the file doesn't parse, then it means that there is a problem with the ontology. So we end up doing a little bit of this job. Better coordination among tools provider, that's something we are working on, trying to also plug in existing tools, third-party software inside AgroPortal or inside OntoPortal, and that's something we like to get better also at, and looking at some of the outcomes of OntoCommons will be also very relevant. The recommendation on principle, best practice, and methods for the creation and maintenance of ontologies, it's a little bit similar to the gap in ontology validation. That's something we do by default, because working with our communities, we help them and we told them about some of the practice we know for ontologies, but not necessarily with a formal validation approach, like, for example, shackle shapes for data validation. That will be a next steps, future steps for us. So those are more or less my slide, and I just wanted to let you know with 2 slides the context in which we are doing that now. So since my last participation in OntoCommons, we started that project that I wanted to mention called Fair Impact, which is a project in the context of the EOSC roadmap. So those of you that are following the European program knows that the European Open Science Cloud is the very big set of infrastructure and services that the European Commission is building for scientists, and we are participating in Fair Impact, which is one of the projects in this roadmap, and that's the only project that really has a work package focused on metadata and ontologies. And so in this work package, we study different aspects of semantic artifacts, ontologies, metadata, standard, and we put and we have, for example, a task force on semantic artifact catalogs. And so that's more or less it. Yes, that's the picture of this thing where we say that we work with the governance, the creation, the mapping, sharing and reuse of those vocabularies, and even doing fairness assessment using methodologies like the one I presented, OFAIR, or Maria's FOOPS software that is also related to OntoCommons. So really, if you're interested in following us a little bit of those activities, join us, or because Fair Impact is really an open project. It's a coordinated support action, a little bit like OntoCommons, with vision to embark people in the discussion related to semantic artifacts in the context of EOSC. So feel free also to join some of our activities. It has already been the case with Eddie and Arco a little bit. So that's all. Thanks for having me, just presenting the overall context on this slide. From the FAIR principle applied to the ontologies, we developed one portal. From one portal, we've been doing several portals in the context of the OntoPortal Alliance, and now trying to push that with the vision that maybe we can provide such a service at the EOSC level. Thank you.
Thank you. Thank you very much, Clément. Thank you very much, Clément. So it's a very informative talk on Ontology OntoPortal Alliance, and I'm thrilled to see the new features on AgroPortal. And yesterday we had a session like the Fair Impact project has presented the latest deliverables and the progress. They are very, very exciting. So before you leave, I'd like to ask if any audience from online have questions for Clement? As far as I can see, there's no questions online. Any questions in the room? No?
Yeah,
you have a question? Yes, please.
Yeah, I mean, this is kind of related to my agriculture work. Can I get Clement's contact information?
That's all. Yeah, Clement, if you can type your email address in the chat, and one of our audience in the room would like to have a contact with you after the workshop. He's interested in agriculture as well.
Yeah, I just did it in the chat. And oh, that's the question and answer. Sorry, I will do it in the chat. And yeah, feel free to reach out to me. And I wish I could have participated a little longer in the presentation in the session today. But I wish you guys a very interesting session, and I will certainly hear about it.
That's very kind of you. Thank you very much, Clement. Thank you. Okay, so I'd like to introduce my next speaker. So I'd like to introduce the next speaker. We have Holger Knoblauch. Sorry about my German pronunciation. I hope I speak it right. Holger, are you online? Can you hear me? So Holger is the lead developer at Top Quadrant, and he is the main editor of the Shackle specification. So he's going to give us a talk on Shackle validation. And Holger, if you prefer to share your screen from your end, you can do that.
I don't think the button is active, but I think it's fine if you show the slides as well.
Okay.
Not many.
It's not active because I was sharing this, but
yeah, can you try again?
Yes, now it should be better. Let me try share screen.
Just so you're independent in changing the slides.
Yes.
But if you prefer, I have them here as well.
Yeah, no, I understand, and that's appreciated. Thank you very much.
Yes, we can see the slides. I can see the screen, and if you can put it into presentation mode.
Yeah. Wherever that is, yeah, I've never done that actually. Where's the presentation?
You can click on slideshow on the right.
Slideshow.
Yes.
Yeah, here we go. Oh, got it. Thank you.
That's perfect. Yeah, the stage is yours. Thank you.
All right. Okay, so let's do this quick. So this is about ontology validation and corresponding tools. In particular, I'd like to talk about Shackle for those who haven't seen that or want to see a different perspective. So Shackle has been an official standard since 2017. In the W3C working group, which had fairly controversial stages to go through to get to that point, but it's now stable and established, and many people are using it now. So in addition to the official standard spec, there is, just to point out, there's another specification called the Advanced Features of Shackle, which is in community draft stage. So it's not official, it's not widely implemented, but it is introducing a number of interesting features that may go into a next version of Shackle. There is also a fairly active community group. Here I have a link or a page, a screenshot of the Discord channel where we discuss Shackle-related things. If you want to join, you're more than welcome. It's a good place to ask questions and see where Shackle is moving in the future. One of the activities that is currently happening, if you're interested in joining, this is a new community group for Shackle, specializing on user interface related tasks. So expanding the scope of Shackle from pure data validation to building user interfaces and declaring richer things than just validation. All right, let's talk about implementations of that standard. I'm pleased to say that most of the graph databases now have support for Shackle built in, And I have a list here, so I hope I didn't forget some of them, but Stardog is there, OntoText GraphDB, Jenna, Allegograph, RDF Fox, whatever. Sorry. And even Neo4j has a plugin for that now. So it is, I think, widely in use in industry, and this shows that it's validated as a valid, useful standard. If you have a database where this is not supported natively, you can fall back to any of the programming APIs that are out there that support Shackle. I have a list here on the right, so Jenna, and so basically there are several Java-based implementations. There's a Python implementation, .NET implementation, Ruby, JavaScript. So all the major programming languages now have libraries that you can use in conjunction with those databases or standalone. There are also various free online tools, playgrounds for uploading your data graph and then validating it. These are just a couple of links. There are more. And in terms of enterprise tools, obviously being from top quadrant, I need to mention that. I want to mention that TopRate Edge. I have a couple of screenshots of that tool as well. So how now probably the most interesting slide. So how is Shackle part of this ecosystem of ontology building that is traditionally dominated by OWL and RDF schema? So I created this little Venn diagram here showing the overlap where OWL and Shackle kind of have the same technologies, same ideas, versus the differences. So let's look at the differences first. OWL and RDF schema have open world semantics, which means that if you can't prove that something doesn't exist, you have to assume it may exist, which means that you can't really use it for constraint checking. So if you want to say, does a person only have two parents, you can't really express this in OWL. You can put a constraint to say maximum number of parents is 2, but it doesn't mean what you believe it means. Yeah. So with closed world semantics in Shackle, this is solved differently. This really has the semantics that you need for constraint validation to have strict limits, let's say on cardinality constraints, and aligns with industry expectation as far as I can tell. OWL uses class axioms and restrictions, and these are very important if you want to do OWL-based reasoning, and they are used for, in particular, from what I can tell, mostly medical domains, a couple of other scenarios. So this is the logical foundation, which doesn't exist in Shackle, but in Shackle we have constraints and shapes that have very similar expressiveness, but solve different use cases. So this is really for inferencing, while this is for constraint checking. And finally, in OWL, you have global property axioms that doesn't exist in Shackle. In Shackle, everything is tied to the context of a shape, basically. I mean, there are ways to also have global properties axioms, but they're not widely used. So typically, you have a more, let's say, object-oriented view where you have a shape at a starting point, and then you declare the properties of that shape. Okay, so where do they overlap, those two worlds? So they are all based on RDF. They both have means to express classes and instances. So things like RDF type and subclass of do exist in both languages and have roughly the same meaning, which means you can also use Shackle. If you just limit yourself to the right-hand side, you can basically do everything that you typically need for ontology modeling with Shackle alone, with a little bit of RDF schema sprinkled in. One differentiator of Shackle that is not present in OWL is its extensibility. So there is a way to extend the language itself by introducing new constraint types. You can express them in Sparkle. And there's also in the advanced features a rule language, which I don't have time to talk about. So how can this be used? So Shackle itself basically defines a language, a vocabulary with which you can, model your classes, properties, constraints. These, because they are declarative, can of course be used and harvested by a number of tools. This is one example of a tool that uses constraint checking with Shackle. This is our tool called Top-Rate Edge, which you can use to enter instances, classes. And here I'm looking at a taxonomy, countries and provinces and stuff. So looking at one particular instance, you can see constraint checks are performed when the data is entered. At edit time, basically, the Shackle constraints are validated. It also suggests fixes if you want to, and you can also run a complete report of all the errors in the current graph from a separate panel, and then go through them one by one. So what you see here also is that Shackle is also used to define basically what shows up when someone wants to enter data. It's basically used to drive the user interface. In addition to being just a validation language, it is controlling which input fields are shown on the screen and in what order. And all that is coming from the Shackle data or shape graphs, the ontologies basically. So previous screenshot was basically editing instances. Here I'm looking at the ontology, which defines the classes and shapes. So this is again Top-Rate Edge, where you can, it shows a class hierarchy with a class called country. You see the details here. And it also shows how you can use Shackle to basically define the properties that are relevant to instances of that class. So for a country, for example, you want to see the labels, you want to see some geopolitical characteristics like the calling code and the capital and the area and so on. So Shackle has built-in features to group them together, to arrange them in an order so that forms can then be built. So, and in this whirlwind run through Shackle here, let me show you some actual examples. How does Shackle look like in practice? So this is Turtle source code. I'm showing two patterns of declaring basically a class and its characteristics. So here I'm showing a class called country. It's defined as an OWL class. It has a label, it is a subclass of some other class, and then it declares a property. And the property is basically a property shape, which points at the URI of the predicate here. And then you can put constraints on that property shape. For example, you can say that all values of the calling code of country must be integers. And when they are entered, there can only be one of them. So here's a max count 1 constraint. And when they are displayed on a form, they should show up under geopolitical characteristics. So in this design pattern here, I've basically defined a class and also made the class a node shape. And the effect is that the class, basically all the constraints here that I've defined, apply to all instances of that class. That's one way of using Shackle, which is probably the most natural one if you're coming from OWL. But there's also a more flexible way of using Shackle, which is to separate the constraints from the class definitions. And to do that, you basically define your class in OWL. Then you define a shape, and the shape specifies that it targets all instances of that class. And then it declares the properties just like that. So two different choices. This one here is a bit more flexible because you can define different views for the same data, while this one is easier to use typically. All right, so last slide, I believe. This is basically reflecting on where we are in the Shackle community at the moment. I believe it's a well-established standard now with a fairly active user community. We see that it aligns with industry expectations because it has closed world semantics, unlike OWL. So it much more naturally aligns with things like JSON schema and XML schema. People in industry like that a lot, from what I can tell. And most databases now have built-in Shackle support. There are stable APIs. And as I briefly mentioned, it's more than just a validation language. It allows you to define classes, property declarations, constraints to validate user inputs, hints to drive user interfaces, shapes for different views depending on who is looking and which perspective you want to take. And it is extensible and very rich in expressiveness. So for me, to summarize that, Shackle is an ontology modeling language for real-world applications. All right, that was my talk. Thank you.
Thank you very much. Yes. Thank you very much, Holger. Any questions in the room? How about online? I think I see a comment.
No, it was from before, from
The last one, is it?
no new one. Sure.
So one of our audience asked for the link to Discord server. Please, could you share that?
Okay, yeah, I'll paste that into the chat, I guess.
Thanks very much.
Yeah, we'll do.
I don't know if you want to say about this or I think later.
So if there is no any other questions for Holger?
Yeah, I see a question on
Yes, there's another one.
the generation.
Yes, yes. Yeah.
There are tools for that, and we have a feature for that as well. The translation from between OWL and Shackle is fairly straightforward because they syntactically overlap very, very much. Yeah, it's really just a slightly different syntax. You can even use Sparkle constructs or insert queries basically to translate from one to the other. There's an online tool for that, which has recently been mentioned in this Discord channel. I think I've mentioned this in one of the slides here. Shackle Play, I think, has features for that built in.
Thank you, Holger. Yeah. So I don't see any other questions, but there's one more coming.
Should I take that?
Oh no, it's yes. Thanks. Thank you. Yeah, I'd like to say the same. Thank you.
Okay. This very last question here, I guess. So are there any other tools except TopRate for Shackle for form building? There's a whole community group actually started for that as we speak. And this will become a de facto standard basically because many other people were interested in that, and this community group is here on that slide. It's called Shackle UI.
Okay, I guess that's the last question. So yeah, thank you very much, Holger, for presenting Shackle for us. And
no, just thank you.
Okay, just thank you. You're so popular, Holger. So yeah, thanks again. And I'd like to invite our next speaker, Jinzhi, to the stage.
Okay.
Can you share Jinzhi's bio?
Yeah, can you hear me?
If you prefer, to
Hi, Dan, can you hear me?
A bit low.
Okay. So can you hear me?
So yeah, so I will have a very brief introduction. So Jinzhi is now an associate professor at Beihang University, and he previously works in Switzerland and also a very active member of OntoCommons. So today he's going to present tool interoperability in model-based system engineering. Okay, stage is yours, Jinzhi.
Okay, so thank you, Lan. Thank you for your invitation. So, okay, so yeah, so this is the first time for me to when I came back to China, so to have the presentation in the OntoCommons economic system. So today, my presentation is tool interoperability in model-based systems engineering. And the presenter of this team, of our team now, I'm as Lan introduced, I'm the associate professor at the Beihang University. And then another authors of this presentation is Professor Wang Guoxin, who is a professor at the Beijing Institute of Technology. So today we will introduce one topic about the model-based systems engineering, which is a very focused area. So I will have a very short introduction about what is the meaning of model-based systems engineering and why we need model-based systems engineering. I take one example of a complex system. So as we know, we have different complex systems like a vehicle. We also have the air engine or aircraft or the spacecraft, like this type of complex system. So when we develop this type of complex system, we will have different stakeholders, like a systems engineer, software engineer, project manager. And also when we implement the system life cycle of the whole complex system, we also have some standardization. We need to have some standardized process and our business model to control the whole life cycle. Also, we will have some enablers like information, tools, data, knowledge, and some type of model. So one very big challenge for the system life cycle is how to make the efficiency, when the people implement the system life cycle, so how to improve the efficiency when they have such stakeholders, such concerns from different aspects of the system. So now some like OMG or in COSI, they propose some idea is that they hope to use some type of model to represent all the information that all the people know them. And then they can use the model to exchange their idea. So, so model-based systems engineering is proposed as a basic technology for people to sharing information among different stakeholders. But still, there's a problem. When they propose a lot of model to represent the knowledge for different systems, so there's a problem is that, so you see, as I introduced in this presentation, there are different type of model. So how to integrate all this type of model into one format? So this is a very big challenge right now. So how to integrate all this heterogeneous data into one standardized format. So this is a very big problem right now and a very big challenge. So let's back to our topic. We hope to use ontology to realize this problem. So we have some survey for different papers. For example, we survey the last 5-year paper and BSc paper related to ontology. So we can see 5 years MBSc papers here. So we can see the ontology is very important related to systems engineering, product design, manufacturing, and all the other aspect. And the ontology concept is near the centric of the whole concept. Also, we survey about 150 papers in the IEEE transactions and in COSI systems journals. So we found also the ontology is a very important topic here. Moreover, we also surveyed 5,000 more papers in the Scopus related to MBSE. Then we found this, of course, ontology is a very important concept in the area of cyber-physical system. So based on this survey, we know ontology maybe should be one of the potential solution for integrating all the heterogeneous data of the model in the whole system life cycle. So, okay, so based on this idea, we create a IOF system engineering working group 3 years ago, since 2020, if my memory was correct. So we hope to develop the systems engineering and the model-based systems engineering ontology based on the IOF ontology specifications. So that's our idea. We hope to create this type of model. So the next step is that we should to understand what is the meaning of stakeholders, what is the meaning of systems engineering, and what is the meaning of model-based systems engineering. So based on the several years discussion in our working group. Now we have a very initial idea about what's the topology among different systems engineering concept and a model-based systems engineering concept. So we can see here we have a systems instance. Also, we have a physical system universal. So we will have a different model to represent the physical system universal and a physical system instance. Then we will always have stakeholder to hear the models. Then the model is developed based on the modeling language, and a modeler is always using the modeling language to develop the models, and the model always represent the different physical system. Also, the stakeholder is interested in different aspects, and then the aspect is represented by the model. So in this case, we can find that, okay, the model can be used to represent the physical system instance and the physical system universal. So based on this idea, I take some of the example of the models in the systems engineering domain, like a compiler, MSIM, Modelica, SimLink, and the SysML. So almost all type of modeling languages, and they have different type of models. So together we think all these models, they will have the MBSE formalism. And then the formalisms including the syntax and the semantics. Syntax include the concrete syntax and the abstract syntax. Here, the concrete syntax means, for example, what the block looks like, what the box looks like here. So we define this type of information is the concrete syntax. Also, the abstract syntax means how the block connect between each other. So in this situation, based on the concrete syntax and the abstract syntax, actually all the models actually they can have some rule. All the modeling tools they have some rules to construct their models. Then when they have the models, they always have each model have the syntax, including the syntax domain. For example, what's the meaning of this block? So they will, in different domain, they will have different syntax. And so we need a semantic mapping between the semantic domain to the syntax in order to describe what's the meaning of each model. So in that case, we are developed the MOF, the framework supporting model syntax representation. So in this MOF framework, so we can see we have the meta model, including all these basic elements for constructing the meta model. The meta model here, so for example, we have different type of model elements of SysML, OPM, BPMN, all these type of modeling language, they will have the basic model elements. Then based on the meta model, we can develop different type of model here. So you see, so all these models, they can be used to represent the physical system, physical world. So including the aircraft, a spaceship. So using this framework, actually we can try to abstract all these model element, meta model for the physical world. So finally, we propose the meta model for MBSE model. So the meta model is here, include the graph, object, relationship, point, role, and properties. I take one example here, so you can see this is the graph. This is the property, like some attribute of each block. And this is the object. This is the role, I mean the two end of the relationships. And this is the relationship, and this is the point, means the port of each object. In this situation, we can use all this meta model to represent MBSE models like this type of model. So finally, based on this idea, we also define the OW model to represent all this information for the MBSE model. And then finally, we hope to we need to transform all these all the MBSE models to the OW models. So you can see here we have the GUPPRE concept like a graph, object, point, property, relationship, and the rows. This concept they are mapping to the class. So you see we are mapping to the class. And then all the intentions such as the include the bound, like this type of the relationship between different type of model. For example, the graph need to include all these objects. So this type of intentions, they are mapping to the object property. So based on this transforming rule, the meta model is the subclass of the GOPPRE concept, the basic class. Then finally, we can use individual to represent the models based on the meta model. Finally, we can mapping the system view, I mean the physical system to the ontology part. In this situation, in this idea, finally, we can realize we already realized one two-chain actually. So you can see here we have different MBSE model, including MBSE methodology, architecture model, and the simulation model. And then we can, based on these MBSE models, all these MBSE models can map into some digital twins or some simulation models like here. So you can see digital twin machine learning model. Even we can use the MBSE model to represent different type of simulation models. Then we can finally all these models can transform into the ontology part. You can see the GUPPRE ontology is here. Then we can try to integrate the GUPPRE ontology into the BFO and the IOF core specifications. Finally, when we have the ontology model, we can transform these ontology models into the knowledge graph model. So that means all these MBSE models, architecture models, simulation model, they can transform to the knowledge graph model. And when we design the reasoning algorithms, then finally we can support the cognitive services for the AI enabling platform. For example, we are developing the model demonstration, the modeling online modeling platform here. So you can see we also have the cloud-based database for the knowledge graph. We're using the huge graph proposed by Baidu, which is an open source database. And also we can support the online decision makings. And also we are developing some iComma communities in order to demonstrate all the open source models. So I take one demo here. So in this demo, we hope when we develop the vehicles here, we use Modelica, Simlink, MSIM, Magic Draw, and some EastADR model in the MetaGraph. So in this case, we need to realize all this model into one OWL model. Then finally, we hope to construct a online demonstrator for all these models. So using the use case through different tasks, including the use case, the MBSE languages, the MBSE methodology, the problems, the values of the models. Also, this is a community for all these demonstrate all these models, and when all the model update to this iComma community, then later all the model can transform to the knowledge graph model. Then finally we will develop the cheating robot in order to realize the intelligent questions and answers based on the existing models in the iComma community. So in this case, actually, you can see different types of architecture model requirement, design structure metrics, and the simulation models in Simlink, in Open Modelica, in MSIM. All these models, they can transform the model into the ontology model based on BFO and IOF. So finally, this model in the future, that's our next step, is that we hope to use all this data to integrate with the LLM, this technology. I mean, we hope to use the LLM to realize the intelligent questions and answers based on the existing model. So conclusion, first thing is that now we have developed the GOPPRE ontology transformer for more than 5 software or models. And all the transformers will be open source in the future when all the transformers are developed. And moreover, based on a Chinese national standard will be realized based on this ontology. Also, we develop a ICAMA community open source website to demonstrate all the modeling use case based on the GeoPPRR ontologies as open data. Based on all this open data, we hope to develop the chat robot to realize intelligent modelings based on the existing knowledge. Okay. Yeah. Hi, Lan.
Okay.
Thank you very much. Thank you very much, Jing. Thank you. Yeah, well, I'd like to maybe also emphasize that the work that Jinju has presented, it's impossible to go details in 10 minutes. And we have the work package on domain level ontologies, and we have a dedicated deliverable on domain level ontology harmonization and development. And we have a focus group in systems engineering. So his work will be also in the final report of this domain level ontology harmonization and development. So I would like to invite anybody who is interested in this work and just keep your attention and staying attention to this. And we'd like to also hear the feedback from you. Okay. So any questions for Jinju in the room? How about online? Okay, I don't see any questions coming up in the room or online, and I know it's pretty late in China, Jinju. So I don't like to keep you awake keep you up late.
Okay.
If there are any other questions coming later, I will contact you tomorrow. Okay. Thank you very much, Jinju.
Okay, thank you. Okay, proceed.
So these are the three speakers online, and we have two more speakers. One is me, and the other is Arco. I'd like to welcome Arco to give a presentation on industry portal. Arco, please come.
Thank you, Len. This is one of the tool which we think that it is deliverable from OntoCommons because it was developed during the OntoCommons time frame, and then also from the support of OntoCommons. So industry portal is an ontology repository. And as you know that we promote the OntoCommons ecosystem, so we consider it a part of it. The purpose of it can be summarized by one of the statement made by one of our external advisory board member. And he thinks that one of the main services that the OntoCommons project can offer is to create a public resource where all the major ontologies, their uses and their users are listed. And industry portal does exactly that. I mean, also it is, I believe, a long-standing requirement because there has been many ontologies being developed for the last 20 years in this domain in both manufacturing and materials. And then there needs to be a solution for sustainability, a solution for version management, and in the new perspective that there should be a provision where they are maintained with proper fair metadata. So industry portal is, of course, as you learned from the previous presentation from Clément, that this is also in the big family of OntoPortal technology. The backbone is OntoPortal. We chose this because then we become part of this community, which is very active, has a very long tradition of dedicated developers and user maintaining that. So we will continue getting their support in future. So just to present how industry portal will play a pivotal role in this OntoCommons ecosystem. So the methodology what OntoCommons recommend is called linked open term, LOT. And if you think these major phases of LOT, here you can see that the features of or the utility of industry portal in some of these phases, specifically in the ontology implementation, ontology publication, and ontology maintenance. I will go over them very shortly. But then we are also extending the industry portal to include new features, which will also let you do some extra functionality, which was not traditionally done by a ontology repository. So this is the link. You can go and see it yourself, and then as it is already alive, I mean, I do not spend much time explaining the interface, but I mean this is a summary that if you maintain your ontology in this portal, and then it looks very elegant with all the information and all the metadata, the submission, the source data, and then many other things at the same page. So how it will help you in the ontology implementation is that we recommend that you reuse existing ontology while you try to develop a new ontology, be it a top-level ontology or mid-level ontology. And industry portal gives you many utilities to find the right ontology. Of course, if you know your ontology, you can use the ontology browser. But then this is very important that you can find from a group of ontology what you need the suitable ontology by searching through some of the concept which you require to model your data or to model your use case. And for that, the class search is very important. You can make use of it, and we use it in many of our activities. But also you can use some sophisticated tool called ontology recommender, where you can actually copy paste your competency question, your unstructured data, your data model, anything, and then it will find you the required ontologies and then give you a similarity score, which will help you to find your suitable ontology. Maybe one ontology is not enough. For your data, you need multiple ontologies, and it will actually group them together to give you the option to use them as it says. Now, of course, OntoCommons, in the business of harmonizing ontology. So this is very important that we include the mapping between the ontology in the portal. There is a feature already which stores mapping. We are trying to enhance it with many different utilities. But at its current stage also, you can see some of the mapping has been stored in the portal, and it will add you. It will let you add new mapping. However, we are trying to extend this feature with SSSOM support, which is a recommended format for storing mapping. We want to include automatic, manual, and tool-based population of mapping. We want to support contextual mapping. That means like you can support multiple set of mapping between two ontologies. And then, of course, we want to maintain the mapping metadata, which is not talked about enough. But we want to support we want to store also information which will be associated with the mapping between ontologies. And of course, it already has a visualization which will give you a nice way to see how the classes between different ontologies are mapped. Now comes to the evaluation part. If you store your ontology, if you find an ontology in this portal, you can evaluate the ontology from many different aspects. The fair evaluation is one part of it, but also there are other evaluation aspects. Say, for example, you can measure the metrics. There are different metrics, fidelity, and then compactness, and all of these. So we will try to make sure that those tools are available. For now, at this current time, we included the fairness evaluator, which I will talk about now a little bit and introduce it. It is already, mentioned by Clément. So not going into detail, but if you go into any ontology, you will see a FAIR score. The important point is that this FAIR score is calculated based on a detailed metadata, actually, which gives you a nice option to provide a lot of detail along with your ontology if you want. And then it will also help you. It not only calculate the score, but then it actually give you a wizard-based guide to tell you where did you, where can you improve your FAIR score and where you can populate more information to improve your FAIR score. And then, of course, you can get the metadata back with an API. This is a very nice feature. And then a lot of other tools. It opens the possibility to build a lot of other tools to search ontology, to integrate ontology using these APIs. Now, of course, just searching the ontology is not enough. You want to use the ontology for your work. So for sure, you can find the latest version and then download the source and use them. But we want to also point out that we recently integrated this tool within industry portal itself. So if you go to any ontology, and then now you can go to Source, which is already integrated as a tab. You do not need to do anything extra. It will give you the nice visualization of this ontology. And then you can go and try to use this tool to edit the ontology also. You will see a presentation on that next. And then, of course, we want that please submit your ontology. As more ontology this portal will get, it will be enriched, and all of this feature will be much more powerful, as it will continue getting more ontologies. So there is a documentation already included, and which will guide you, but then of course you can contact us for support. So as a conclusion, I say that our primary goal is to continuously maintain, update, and collaborate with the OntoPortal community to keep this tool alive and in shape. Of course, we want to build a communication channel with the users and the collaborators, the developers, to make a vibrant community around this tool. Of course, it will be enhanced with new tools and integration, and we will work on the mapping more. And tomorrow there is a presentation on our new feature of the mapping, so please be there, and then you can get some sneak peek of this new development we are doing for this. And in the end, OntoCommons has supported us to deploy this tool, but we need continuous funding, sponsorship, and endorsement. So if you think this is a meaningful work, useful work, please think about supporting this work. And that's all from me. Thank you.
Thank you, Arko.
Oh.
Yes, questions. And any questions for Arko in the room or online? Okay, I don't see any questions. So thank you very much, Arko. Look forward to the presentation tomorrow about the visualization of new features on Industry Portal. Okay, so I think I have around 4 minutes to give my own presentation. It's not a presentation, actually. It's an interactive activity. I have a live poll. I want to collect feedback on the OntoCommons ecosystem roadmap regarding the toolkit. So I have very simple 9 questions, and I will show it online. So you can have your mobile or you can have your laptop by scanning a barcode, QR code to join the live poll.